Today is October 13th, 2025. As autumn leaves begin to fall across the northern hemisphere, thoughts naturally turn to the approaching winter. Recent data from global climate monitoring agencies' animated global anomaly map shows cooler blues and warmer reds. The winter of 2025-2026 could deliver a colder and more impactful season than many have experienced recently. Global warming trends still show milder winters on average, but that doesn't rule out big seasonal departures. Oceanic drivers, atmospheric drivers. Those drivers are showing signs of increased probability for prolonged cold outbreaks and substantial snowfall. Climate is a complex system, not a simple linear warming. Initial signals are not uniform across locations. These signals represent a statistical shift in the odds. Imagine loading the dice in favor of colder outcomes. This essay will break down the primary factors influencing this winter's outlook. At the heart of many long-range winter forecasts lies the El Niño Southern Oscillation, or ENSO. This is a naturally occurring phenomenon involving fluctuations in ocean temperatures in the equatorial Pacific. The two most famous phases are El Niño, characterized by warmer-than-average waters, and its counterpart, LaNiña, defined by cooler-than-average waters. These temperature shifts release vast amounts of energy, and they profoundly alter atmospheric circulation patterns around the globe. ENSO during the winter months provides the foundational layer for other, more variable factors, setting a baseline for temperature and precipitation across continents. Recent observations and model projections for late 2025 are pointing toward a transition. The latest data shows a distinct cooling trend across the central and eastern equatorial Pacific. Many leading climate models now forecast a high probability of a weak to moderate LaNiña, or, at minimum, ENSO-neutral conditions by winter. This is a critical development. LaNiña typically reconfigures the jet stream over North America, creating a wavier, more amplified pattern with major consequences for winter weather. The jet steers northward over Alaska, then southward over the central continent. That configuration acts like an open door for frigid Arctic air to spill into the northern and central U.S., leading to more frequent and intense cold spells. It also brings stormier, wetter conditions to the Pacific Northwest and the Ohio Valley, while the southern U.S. often stays warmer and drier. In East Asia, LaNiña can enhance delivery of cold Siberian air, increasing the chance of harsh winter conditions. No two LaNiña events are identical. The strength and location of the coldest Pacific waters changes the outcome. A weak LaNiña has a milder influence, allowing other climate drivers to dominate. Still, the current tilt toward LaNiña, or cool neutral, is a major piece of the puzzle, pushing the odds toward a colder, stormier winter for some regions, and signaling that winter 2025-26 could deviate from recent milder seasons. These are based on observable data and well-understood teleconnections. Examining these drivers builds a more nuanced, evidence-based forecast. Each element is a piece of a massive interlocking puzzle. The Arctic has long been considered the planet's refrigerator, but its role in our weather is becoming more complex and dynamic. One of the most critical variables we monitor is the extent of Arctic sea ice, especially at the end of the summer melting season in September. In recent decades, the trend has been one of significant decline. Less sea ice means more dark. Open ocean water is exposed to the sun's rays during the late summer and the early autumn. This open water absorbs more heat than reflective ice, leading to a warmer than normal Arctic Ocean. This phenomenon, known as Arctic amplification, has profound downstream consequences for winter weather in the mid-latitudes. A warmer Arctic Ocean in the autumn releases its stored heat back into the atmosphere, warming the air directly above it. This warming can reduce the temperature difference between the polar regions and the equator, which is the fundamental engine that drives the jet stream. A weaker temperature gradient often leads to a weaker, more meandering jet stream, instead of a straight, zonal west-to-east flow. It can develop deep waves and undulations. Large north-south wobbles transport air masses between climate zones. These wobbles allow frigid Arctic air to plunge southward into North America, Europe, Asia. The term polar vortex has become a household name, often associated with bone-chilling cold. In reality, the polar vortex is a normal and persistent feature of our atmosphere. It is a large-scale circulation of strong westerly winds high up in the stratosphere, miles above the weather we experience. During winter, these winds encircle a vast pool of intensely cold air over the polar regions. When the polar vortex is strong and stable, it acts like a well-guarded fortress, keeping the frigid air locked up in the Arctic. Mid-latitudes then typically see relatively mild winter conditions. However, the polar vortex can be disturbed. Large atmospheric waves from the lower atmosphere can push up and hit it. That push can cause it to slow down, or to wobble, or even to split into two or more smaller vortices. That dramatic change is called a sudden stratospheric warming. The stratosphere over the pole can warm by tens of degrees Celsius in just a few days. The disruption doesn't stay aloft. Over weeks, the weakened winds can translate downward. They can then reshape the jet stream in the troposphere, producing big shifts in weather across the northern hemisphere. A weakened or split polar vortex is a reliable precursor to severe cold outbreaks in North America, Europe, Asia. The breakdown lets dense, frigid air escape and surge southward. These events often cause the most memorable cold snaps of a winter, including record low temperatures and dangerous wind chills. Forecast models and observational precursors for winter 2025-26 are showing an elevated chance of such a disruption. While the Pacific and the Arctic play starring roles, the Atlantic Ocean has its own powerful script for influencing winter weather, particularly for eastern North America and for Europe. A key climate pattern here is the North Atlantic Oscillation, the NAO. The NAO is a measure of the atmospheric pressure difference between the semi-permanent high-pressure system near the Azores and the semi-permanent low-pressure system near Iceland. Its phase, whether positive or negative, dictates the strength and path of the westerly winds and storm tracks across the North Atlantic. In its positive phase, the NAO features a stronger than usual pressure difference, resulting in a powerful, direct jet stream that pushes mild, moist maritime air across northern Europe, leading to wet and relatively warm winters. At the same time, this pattern often brings colder and stormier weather to eastern Canada, but can shield the eastern United States from the worst of the Arctic cold. Conversely, the negative phase of the NAO is characterized by a weak pressure difference, which slackens the jet stream, causing it to buckle, and often allowing a blocking high-pressure system to set up near Greenland. A negative NAO is a classic calling card for cold winters in Europe and the eastern United States. The Greenland block acts as a major atmospheric traffic jam. It forces mild Atlantic air southward and opens a direct pathway for cold Arctic air and cold Siberian air to pour into Europe. For the eastern United States, this pattern can also favor the delivery of Arctic air and contribute to the development of powerful snowstorms, or nor'easters, along the coast. Looking ahead to winter 2025-2026, a cooler patch south of Greenland, the cold blob, can favor a negative NAO state. Some models hint the NAO may hover neutral to negative, working in concert with LaNiña and a potentially weakened polar vortex, a powerful trifecta for increased cold and snow risk. Another crucial, though sometimes overlooked indicator for winter weather in the northern hemisphere is the extent of snow cover across Siberia during the month of October. This factor operates on a simple but powerful principle of atmospheric physics. The white snow reflects incoming solar radiation back into space, preventing the ground from warming up. This leads to the rapid cooling of the land surface and the air directly above it. This process helps to build and intensify a large, dense dome of cold air known as the Siberian High. This semi-permanent high-pressure system is a dominant feature of Asia's winter climate. The faster and more extensively snow cover builds in October, the stronger this high-pressure system tends to become by early winter. A robust Siberian High acts as a massive reservoir of frigid air. Its strength and position play a critical role in dictating the severity of winter, not only for Asia, but also for Europe. The cooling over Eurasia can enhance the propagation of atmospheric waves upward into the stratosphere, the primary mechanism that can disrupt the polar vortex. An unusually snowy October in Siberia can serve as a precursor to a sudden stratospheric warming later in the winter. As we progress through October 2025, preliminary observations are showing an aggressive start to the snow season across large swaths of Siberia. If this trend continues, and the month ends with well above average snow cover, it will be another significant checkmark for a colder winter. This signal would bolster the forecast for a volatile polar vortex and increase the odds of severe cold outbreaks moving from Asia into Europe. It's a prime example of how an event in one remote part of the world can set off a chain reaction with far-reaching consequences for millions of people. Translating these large-scale climate drivers into specific regional impacts helps to clarify what a colder winter might mean for different parts of the world. It is crucial to understand that these are broad-scale tendencies, and local weather will still vary. However, The convergence of LaNiña, Arctic conditions, and potential atmospheric blocking raises the probability of specific outcomes. For North America, the primary impacts are likely to be concentrated in the northern tier of the United States and across Canada. The classic LaNiña pattern, potentially amplified by a disrupted polar vortex, favors a colder-than-average winter for the upper Midwest, the Great Lakes region, and the Northeast. This setup increases the risk of prolonged cold spells, where temperatures remain below freezing for many consecutive days. The storm track is often active in these regions as well, leading to significant snowfall, including lake-effect snow events downwind of the Great Lakes. The Pacific Northwest can expect a cooler and wetter-than-average season with abundant mountain snow. In contrast, the southern U.S., California, Texas, Florida, is likely to experience a warmer and drier winter, raising concerns about developing drought. The Central Plains will be a battleground zone, with sharp swings between mild air masses and intensely cold air masses. Across the Atlantic, Europe's outlook hinges on the NAO and blocking highs. If negative NAO dominates, Northern and Central Europe face higher cold risk, with persistent freezes and occasional Mediterranean storminess. Knowing that the odds are tilted toward a colder, snowier winter allows us to move from forecasting to action. Proactive preparation is the most effective way to minimize disruptions and stay safe. This is the ideal time to have your heating system serviced to ensure it is running efficiently and safely before the first cold snap arrives. If you use a fireplace or wood stove, have the chimney professionally cleaned. Check insulation and seal drafts to conserve heat and lower energy bills. Prepare for the possibility of power outages and difficult travel. Assemble a home kit with non-perishable food, water, flashlights, extra batteries, a battery-powered or hand-crank radio, and warm blankets. Do the same for your vehicle. Include blankets, water, snacks, a first aid kit, and a portable phone charger. Always check weather forecasts before traveling and avoid roads during severe winter storms. Dressing in layers is the most effective way to stay warm outdoors. Municipalities should review snow removal plans, ensure adequate salt and sand, and confirm emergency vehicles are fully serviced. Inspect the resilience of the local power grid, and ensure hospitals and emergency shelters have reliable backup power. Communicate clear safety messages and warming center locations, especially for the elderly and those with low incomes. Farmers should secure feed, shelters, and water. Businesses should implement continuity plans, including remote work, to prevent losses. The evidence gathered from our planet's oceans and atmosphere points toward a noteworthy shift for the winter of 2025-2026. The evidence gathered from our planet's oceans and atmosphere points toward a noteworthy shift. A collection of key climate drivers, a developing LaNiña, low Arctic sea ice, an early start to Siberian snow cover, and patterns in the Atlantic, are collectively increasing the probability of a colder and snowier season for significant portions of the Northern Hemisphere. The regions with the highest risk include the northern United States, much of Canada, northern and central Europe, and East Asia. This forecast is not a certainty, but a data-driven assessment of the shifting odds. A single cold winter in some regions does not negate the overwhelming scientific consensus on long-term global warming. It highlights the complexity of the climate system. A warming Arctic can paradoxically lead to more extreme winter weather by destabilizing patterns like the polar vortex. We are moving into a climate with more extremes, and this winter may exemplify that volatility. The signals are strong enough to warrant a heightened state of readiness. Early preparation is our best defense. Stay informed and prepare early. Pay attention to updated forecasts. Check heating systems. Prepare your home and vehicle. And review your family's emergency plan. By respecting the power of nature and preparing for its possibilities, we can navigate the winter of 2025-2026 safely and effectively.